Yeah, so the recording has started. Yeah. So once again, welcome to this event. I'm Krishna Gaur, GDSC and IIIT, and this is our first workshop in the series of I would say 3 to 4 workshops where we'll be exploring ML and AI under GDSC ML Jam, ML Study Jam. The first workshop will be taking you through the basics of ML AI and will be kind of giving you intuition, like how ML AI actually works. As we will move forward, we will be doing stuff, building some cool models, which will be really simple. They won't be that hard to implement, and they would be beginner friendly. Without wasting any more time, let me share these slides with you. So, is my screen visible? I just need a confirmation from anyone of you. Okay, so yeah. I hope it is visible now as well. Okay, so here is a small video from GDSC. Let's check it out. Do tell me if you could if you could hear the audio.
Our ability to learn and get better
So is the audio available? Can you hear it?
Yes, sir.
Okay.
at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so.
So as you can see in the beginning, they start with a child, and a child when he begins his life, he is like not able to do his basic task as well. He needs someone. But as he grows up, through experience, through environment around him, he do some mistakes, learns from them, and grow better and better. Similarly, in machine learning and artificial intelligence domain, we try to teach a machine how to get better with a given task without writing a code, a conditional code, so that it could perform that thing. So it is all a big mumbo jumbo of statistics and mathematics, but a very, I would say, beautiful conjuncture of statistics and computer science. So let's move forward.
Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future.
Yep. So when we are children, we are like pointed at things and say like this is a dog, this is a cat. Same thing we can do with the computers as well. Now, what our mind process in the back is, okay, if it is something flurry, it is going to be a dog or a cat. But if it has a more height, then it would be basically a dog, not a cat. If it is small, it is going to be a cat. So those kind of statistics, so these are statistics that we have learned about dog and cat by generalizing dog and cat. Now, someone might argue, what if we give a pug dog to this kind of model, which only sees through the height? Then yes, it would give a wrong output. But it does not look only at the height. It also look at different other features which are available, which are present in a dog and a cat. So you can see a dog has a longer nose, a dog has some other distinct features which a cat does not have. So while we are showing our computer these images of dogs and cats, what it does is it tries to extract data from those images, which it could use in future to distinguish between a dog and a cat. So this phase is called the training phase, where we show the computer some images and then we tell the computer like, okay, this is this and this is this. This is called the training phase, or we can also say that computer is learning from its experience. Okay, now let's continue.
It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog.
So as you can see, there are different images, and we are trying to distinguish. We are kind of creating a separating boundary that whether it is a dog or a cat. So we say what all falls on the left on the line are cats, and what all falls on the right of the boundary or the line are dogs. So the thing is, like, we update this line every time we see a uh, new cat or dog. So in our mind, in our back of mind, we are updating this kind of line. This same behavior is trying to is like we try to replicate it by our computers as well.
But of course, there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.
So yeah, as you can see, there are wide applications of machine learning, and yeah, you would have seen that meme where machine learning models identify a cat as a dog. So yes, the machine learning models do make mistakes, but uh, we can train them so that they make lesser mistakes in the future. So again, the thing is, you gain experience from your past, you try to improve it yourself, so that you can become more and more capable in the future. Okay, so I would ask you to like be a bit interactive and let's play a game. So I will drop a link over here, which is of this Crowdsource app. So can you please download this app, this Crowdsource app? We'll wait for 2 minutes. Okay. So I hope you would have downloaded the app. Uh, those who have downloaded, can you please raise your hands just for once? Uh, yeah, I can see. So what you have to do is downloaded the app and open the smart camera task. Go to smart camera task and open it. So have you reached to this step, opening the smart camera task? So those, yeah, okay. So now try to point it at some object. What do you see? So let's say if you have something near you, let's say a bottle or even your laptop, try to point that camera towards it. So has anyone tried to point the camera to the bottle or to the laptop? And has was the app able to tell you that yes, it is a camera or yes, it is a bottle? If you got any answers, please put it in the. You can put it in the chat or you can open your mic. Both will. Okay. So Prasoon, can you please open your mic if you don't have any problem?
Yes, sir.
Yeah. So which object did you point it at?
A mobile phone.
So was it able to detect it as a mobile phone or a smartphone?
A phone, basically.
A phone basically. So kind of it has generalized that it is a phone.
Yes,
Anyone
sir.
else who would have pointed at something other than mobile phone? Please, I would
Computer
request you
mouse.
to
I
computer
pointed
Computer
at pen.
a
computer
pen.
mouse.
Yeah, I didn't recognize it. It recognized it as a screwdriver.
As a screwdriver. So what you
Yeah.
can do is you can say like you have not recognized it as a pen, right? So you can then submit a report. Okay, this was not well recognized. It is a pen. Then the model will be gaining the experience from you, and it will get better and better. Yeah.
Okay.
Some of you have said that you pointed at a computer mouse. Was it able
Yes,
to?
yes, sir. Sir, he
Yeah.
recognized.
Yes, yes, go ahead.
Sir, he has recognized
Okay,
to the
great,
computer mouse.
great. So, how does a computer able to recognize the computer mouse? What things goes behind? Like, I point a lamp. Okay, a lamp was also recognized. Great. So you point at something and it was able to recognize. Okay, this was a lamp or this was a computer mouse. And yeah, it failed at one instance also. It looked at a pen and said that it is a screwdriver. So you can see the pen and screwdriver, the structure are not much far from each other. Both are like long and they have this kind of structure where they become pointy at the end. So yeah, it could recognize it as a pen drive as a screwdriver as well. But so machine do make error, but that is another part. But how do they learn? This is the first part. So how do they learn? So yeah, how does the image identification work? How is it recognizing objects and how we could program this? We will be learning all these things throughout this three workshop that we will be taking. So first of all, how does the image identification work? So the model which this app, Crowdsource app is using has been trained on billions of images. We have shown the computer a billions of images of let's say a mobile phone, and we would have said that okay, this is a mobile phone. and told the computer, see this image, this is of mobile phone. Then we saw, gave it a pen and said, see this image, this is a pen. And then after some time, we pick up an object randomly and show it. Okay, now tell me what it is. So let's say if I give him a pen and it recognizes it as a screwdriver, then I will punish the computer in some way so that it would remember that okay, I last time I recognized it wrong. I should make amends and make it and recognize it uh, right next time. So now the thing is, how is it recognizing? So a model tries to extract information from the images. When you look at the images, when you look at flower, okay, when your brains look at flower, how would you tell that it is a flower? What is the thing inside a flower that makes your brains to say, yeah, it is a flower? Anyone? Okay, so let me just ask the question differently. If I give you a pointy object, would you recognize it as a flower? Would a pointy object be recognized as a flower? Yes or no? Just yes or no. You can write it in the chat or you can open your mic. No. Uh, so a pointy object, no, yeah, right. A pointy object would not be recognized as a flower because we know a flower has soft edges, right? So you see, your brain has recognized, okay, this kind of object has this kind of properties. This is what we are going to teach a computer. Like, okay, if you see a flower, try to learn that this flower has this kind of properties. So you might think like things are going in air, okay, we are trying to tell the model, okay, if you see this kind of thing, extract properties and all this a big mumbo jumbo and inside it, it is all a if else statement going on. But believe me, there are these are not if else statement. We have certain frameworks, we have certain statistical and probabilistic frameworks which we use to extract information from these images and which is then applied which is then used as an experience to recognize different objects in the future, and we will learn these things in the future workshop. This is the first workshop is just to like get you through things like what different things are. Okay, so you can play another game if you want. I will share you the link. It is quick draw game. Let me just copy the address and paste it here. You can play this game in your free time, and yeah, it is a fun game. So yeah, okay. So as you said, as I said, like recognizing something could be rule based. So if I could have, in the case of dog and cat, I could have said that if the object dot height is greater than 10, so if the height is greater than this much amount of parameter, then classify it as a dog. If its color is let's say brown, then or golden, then identify it as a dog. If the length of tail is long, then identify it as a cat. If the height is short, then identify it as a cat. Now this is a rule based approach. This is a rule based approach which was tried by people before the machine learning. But what we do these days is we want to achieve a goal. We give him different samples and we tell them, okay, if this is the output, this is the output, and the model has to extract information from it. So yeah, so let's say yeah, so you have you let's say now, as important as it is to understand what machine learning do, it is also important to understand where to use machine learning. So let's say you have a task to alphabetizing a list of songs. So what you have to do is you have to sort the list of songs based of in the alphabetical order. What will you do? Will you use a machine learning algorithm for it, or will you write a simple sorting code like a bubble sort or a merge sort, anything? What will be your approach? You can drop your answers in the chat, or you can open your mic. Okay, so simple sort approach or rule-based approach. Yeah, you could have used a simple algorithm instead of machine learning task for doing this, because this task is easily implementable by simple sorting algorithm. We don't need such complex machine learning algorithm for it. Then why do we not use it for dogs and cats? Because we do not use it for dogs and cats, because dogs and cats have so much varieties among them. There are so much varieties of dogs, so much varieties of cat, that you cannot manually sit down and write if else code for each of the condition that you see. And what if in future you see a dog which your programs classifies as a cat? Then you have to go through your whole code, check which if else statement produce the wrong output, and then you have to say, okay, this has produced a kind of wrong output. So this has produced the wrong output. So change this line of code. That would be a lot of work to do, right? So that's why we use a machine learning based approach over there. Just a second. Okay, so moving on. Yeah, alphabetizing a list of song titles, you will be using a rule based approach. Now, okay, ranking a web search result. What approach would you use? So let's say you have searched for Django, okay, or you have searched for Java. What would come? Java the island or Java the programming language? Uh, you can try it yourself in your browser. Go and just give it a try. Search for Java and just tell me what output comes. Java the code or Java the island.
Programming language.
Programming language. Okay. Code. Yeah, right. Because while going in your OOPS course, you must have searched for Java a lot of times, or since you are programmers, you must have searched for Java a lot of times. So now your web search knows that, yeah, if it is Java, and since you are a programmer, they have known from your previous searches, they have learned from your previous searches what results to show to you. Similarly, if you would search for Django, which is a backend based framework, and if you would not have previously searched for Django as well, it will give you output of the programming Python framework for backend, not that the movie Django Unchained, because it has learned that, okay, you are a programmer, you are more inclined to programming things, and that's why you would have searched for this. You would have That's why it would have showed you the Django as a programming language, not the movie. So yeah, so it would have been a rule-based as well as machine learning approach. It could have been rule-based, but yeah, machine learning approach would have been better because it would have learned from your past behaviors. Okay, this is interesting one. I hope most of you would know the answer. Predicting house prices based on location. What will you use? Rule-based or machine learning? Predicting house prices. Can anyone tell? Like you are giving a location and you want to predict that what is the house price. So what would you use? A rule-based approach or a machine learning approach? ML algorithm. Okay, ML algorithm. Let's see. Yep. We will be using a machine learning algorithm because the variety of data. So you can see when the data set is very large and very diverse, we tend to use machine learning approach. But when the data is small and we can clearly see that what steps we have to take, in that case we use a rule-based approach, which we use for sorting song titles. Okay, so these are some other yeah. So let's have a look at. In a rule-based approach, what we do is we define rules and the improvements come from algorithm and network. So what we do is we define some rules and see if if it works with our rules, then we say okay, it's good. But okay, let's take an example of let's say competitive coding. So you guys must have given some kind of competitive coding rounds on Code Chef, Code Courses, or even Hacker Earth, Hacker Rank. So if you look at a problem, you write a code for it. And what if the test case for that code doesn't run? You make some changes to the algorithm. You try to go through your whole code, see what error could have occurred, and you make those changes. Similarly, in rule-based approach, we define rules. We try to test it on different subjects or test cases, and we see that whether it works on those test cases or just this rule is failing. But what we do in machine learning is we do not define rules. We learn patterns from data and the improvements come from additional data. So you see, you give him some new photos and see whether it works well or not. So yeah, in rule-based approach, our goal is to define rules and then improve those rules. In machine learning process, the machine learns from the patterns from the data. And yeah, each has its benefits. So when you can clearly see that the data is not much diverse, you can clearly find a differentiating thing between the two classes. If say, let's say you want to differentiate two classes, and you can clearly see a rule, then you can use a rule-based approach. No need to use machine learning algorithm for it. But if a data is very diverse and you cannot define a rule for each of the diversities in the data, then yeah, it is good to use a machine learning approach. Okay, so now we have an let's have a look at this video.
Suppose you have a great business idea and you've already gone through the effort to frame it as a machine learning problem. What next? How does your idea become a working machine learning solution? The process has
So suppose that you live in a world where no one has implemented house price prediction by now, and you are the first one who got an idea of predicting house prices from their location. Okay, you have understood, okay, I will use a machine learning algorithm for it. But how would you implement it?
3 phases: data, modeling, and production. In the data phase, you identify the input data that your machine learning system needs to make successful predictions. Data may come from databases, log files, web pages, and even other machine learning systems. Once you identify data inputs and sources, you use statistical tools to draw insights about the data. The better you know your data, the more useful hypotheses you can make. Data rarely comes in an ideal state. Data needs to be collated, possibly by joining different data sources, and cleaned for the machine learning model to work optimally. Cleaner data results in better predictions. For a machine learning problem, you start with the input data and convert it into features. Features are key properties of the data.
Okay, so as we said that if we have identified our problem and we have thought of a solution, now what? Since a machine learning algorithm requires a lot of data, first we need to fetch data. So in the house price prediction problem, we have to go at different locations, collect the data. Like if this is the location, what is the house price? If this is the location, what is the house price? This is the step of extracting data. Now if your data is clean, let's say you have created a data which has 100 rows, and out of those 100 rows of 50 you know the location, and but you do not know the price. So will that data be useful? No, it won't be useful for your machine learning algorithm because that data is incomplete. In that case, you have to perform some step to clean that data so that it could be used by your machine learning models. Now, machine learning models tries to extract statistics from your data, and if your data is not complete or not clean, it won't be able to extract some good statistics from it, and hence the working of your machine learning model, the success of your machine learning models depend on the data that you give it to it.
For a supervised machine learning problem, you transform the outcome into labels. Labels represent the intended output of the machine learning system. Joining data sources, cleaning the data, and engineering the features and labels takes time. Plan on spending a large portion of your time in the data phase.
So yeah, so what they said is you have to look extract data from a lot of sources. From a lot of sources, you have to extract data, and you have to also look into the credibility of data coming from different sources. Let's say you might go into some location and you want to like ask them what is the house price, what is the average house price at your location. They might over exaggerate, or they might tell you undervalue their houses. That kind of things you also have to take care into, and then you have to clean your data as well. This thing takes a lot of time while we are doing machine learning.
Modeling phase. Along with the features and labels, you set up the kind of machine learning system needed, called the model. Researchers have created all sorts of machine learning models, from simple to complex.
Okay, so by now you would have a lot of time saying me model. But what is a model? A model is just a statistics or are just the statistics which has been extracted from your data. And what it does is it tries to replicate your original system and says if this is it, then this is that. Okay.
Some models classify data. Other models predict numeric values. Tools like Google's TensorFlow support many types of machine learning models for various uses.
Yeah. So TensorFlow and sklearn, these are the most used libraries in the machine learning domain. There are other libraries as well, which are PyTorch, and they all are the TensorFlow, PyTorch, and sklearn. They are available in Python. TensorFlow is also available in JS, but most of the people use Python for machine learning.
Before a model can make predictions, it needs training, which is like sending the model to school. First, there are lessons to learn from the data. Along the way, there are quizzes to check knowledge and correct any misunderstandings. In the end, there's a final exam. When training the model, you split the data into 3 sets: training, validation, and test.
So yeah, so when we are training a model, we split it into 3 sets: training, validation, and test. What happens is the training phase is like going to school and looking into the chapters and trying to extract statistics from it. Then the validation is kind of your quizzes that you go through, different quizzes that you go through. So these are some kind of checks while the process of training to see whether you are on the right track or not. Whether you are on the right track or not. And then we finally have a test. And if our model pass the test, let's say we are very strict to our model, we are very strict in our training process, and we say if you achieve a score of 50 or if you achieve a score of 70, then only you will pass. So yeah, it has to take a final test, and then it is finally used.
The training set corresponds to lessons. Here, the model processes data for the first time. It starts to infer patterns in the data to help make predictions. After you've trained the model once, you quiz it using the validation set. Based on how well the model does on the quiz, you may decide to adjust the model settings, or hyperparameters, which are like dials and switches for changing the model's behavior, and retrain.
So yeah, when you go through different quizzes and see, yeah, I have made this kind of error in this question. You try to go back to that question. You try to go back to that chapter and try to see what error I made at that time, and then you try to rectify it. Similar things we do over here.
the model again to give it the quiz again. The goal is to iteratively find settings that provide the best model quality on the validation set. When the model meets your success criteria, it's time for the final exam. Feed your model the test set. If the model predicts well, it passes the course and is ready for real use. Once your ML system is ready for the world, it's time to move the system into production. For starters, your system may need integration into a product. You need to figure out what this integration looks like and whether your model interacts with users. Models may need retraining on a regular basis with new data.
Yeah. So once you have created a model, okay, so it has a code, then how would you run it? Let's say you have written a model in Python and you want to use it on mobile, but mobile supports Android, and for Android you need Java. How would you use it there? Furthermore, if you want to use, again the model is written in Python and you want to use it on your front-end server, and the front-end server is written in JS, it could be React JS, Angular JS, or plain JS as well. And how would you use it? So these kind of questions we will be answering through these series of workshops. Okay. Yeah. So much we have a complete process for machine learning. So we first of all we focus on our user, what our user is, and what is their objective. So let's say our users are forest officers, and their objective is to find out whether the animals coming into the camera feed, they are uh, they are like carnivores or omnivores. Okay, so this is our objective. Then we have to collect the data. So we will take those photos and see, okay, this animal, this is a carnivore. This, so if we see a tiger, we say, okay, tiger, this is a carnivore. Or let's say carnivore and herbivore. So this is a tiger, this is a carnivore. And then we have a deer, this is a omnivore. So yeah, so you see, you collect the data, then you train the model and test it. Once you have completed the process of training and testing, what you do is you predict your, you use your model for prediction and evaluation, and you give it back to your user. Now, let's say that your model does not perform well. Then what it will do is you will go back to this data collection step. You will collect data again. You will again train your model and again predict it. So you can see it is a kind of iterative approach. We do things multiple and multiple times until we get a real good model. And we will never be getting a real good model. A computer model, a machine learning algorithm can never achieve 100% accuracy. There would be something out there which it could fail. So yeah, there is always a scope of learning new things. Okay, yeah. So you would have heard of this. This is a very important diagram to make the picture clear in your mind. So machine learning comes in a vast domain of artificial intelligence. What artificial intelligence tries to do is tries to replicate what a human can do. So machine learning is a subdomain of artificial intelligence, and deep learning is even a more like is a subset of machine learning. So what we will do is we will first in today's in this workshop we went through just the basics of machine learning. In the next workshop we will explore machine learning in deeper. We will see how a model extracts feature, and then in the next workshop we will go through deep learning. So the goal of these three workshops is to give you enough knowledge, or to give you some kickstart so that you can start your own journey of machine learning, artificial intelligence, and deep learning. Yeah. So this is it. This is it for today, guys. If you have any doubt, you can ask me. Like you can ask any kind of doubt, like how to get started, what courses to begin with, or anything related to machine learning and artificial intelligence. Just shoot your doubts. Yeah. Ankur, you can stop the recording. Let's not record the doubt session because someone might not feel comfortable with it.